In this video, we are going to graph solutions to linear inequalities in two variables. So first, let's just start with recalling how to graph inequalities. When we had just one variable and we wanted to graph x is less than 8, we would have an open circle at 8 because we're not including that value, and then we would shade to the left because that's less than. If I wanted to graph x is greater than or equal to 2, I would have a closed circle at 2 because I'm including that value, and then I would shade to the right because those are the values where x is greater than 2. So when we had inequalities like these, we had more than one solution. We had a range of solutions. For example, for this one, every value that was less than 8 could be a solution. So when we have a linear inequality with two variables instead of just one variable, all ordered pairs or points that make the equation true are solutions. So instead of it just being a range of numbers, it's going to be a region on our graph. So let's see some examples of what that looks like. So we're going to work up to graphing this linear inequality, but first we're going to start off just by plotting our boundary line. So our boundary line is just what the line would look like if we didn't have an inequality sign here and we just had an equal sign. So this is in slope-intercept form. We should be comfortable with graphing this. We're going to start at a y-intercept of -1, so that's on the y-axis where the y value is -1. And then from there, our slope is 1, so we move up 1 to the right 1, up 1 to the right 1, and so on. We're going to make this boundary line solid because here we have this sign where it's less than or equal to. So that means we're including all the values that are on this line. You can think back to when we had these signs here where it's less than or equal to or greater than or equal to. We drew a closed circle when we were doing inequalities before because we were including those values. So we'll do a solid boundary line whenever we have these signs. When we have an open circle before, that was because we weren't including a solution at that particular point. Like it'd be like x is greater than 2, so we didn't include 2 as a solution. So in those situations, we'll have a dashed boundary line, which looks like this. Since our boundary line is y is less than or equal to x plus 1, we're trying to figure out where are the y values less than our boundary line. Are the y values less than our boundary line above the boundary line, so in this area, or below the boundary line in this area? So it should end up being that all the values that are below our boundary line here are where the y values are less than or equal to x minus 1. So any point within this area will be a solution to our linear inequality. And we can test that out. Let's just say we pick the point, let's pick this point here. That point is the point 1, -3. So if it's a solution to our inequality, that means I can plug in this number for x and this number for y, and my inequality will be true if it is a solution. So plugging that in, I'm plugging in -3 for y and 1 for x. So -3 is less than or equal to 1 minus 1 is 0, and this is true. You could test a point that's here or test some other point that is not part of the shaded region, and it should not make the inequality true. So if I test the point -3, 3, this is not part of our shaded region, so it should not make the inequality true. If I'm plugging in 3 for y, and I'm comparing that to -3 minus 1, -3 minus 1 is going to be -4, which is not true. Therefore, that point here is not a solution, which is correct because the solutions we have are all within this shaded region. On this side, we have the inequality we had earlier where y is less than or equal to x minus 1. Because it's equal to, we had this solid boundary line, and because it was less than, we shaded all the values that were below this line. On this side, we have the solution to the inequality y is greater than x minus 1. So because this is greater than but not including x minus 1, we're going to have a dashed line here to represent it's not including any of the points that are on this line as a solution. And then because y is greater, we're shading all the values that are above this line. Okay, so let's try to graph some of these. We're going to start first just by writing out the boundary line. And then from there, I can figure out whether it needs to be solid or dashed. So if this were my equation, I'm going to start at my y-intercept of 5. And then since my slope is -9, I move down 9 spaces and to the right 1 space. So this would be my next point. The next thing I need to do is figure out whether it's a solid or dashed line. So when I look at this, I'm looking at my inequality sign. Because this sign is less than but not equal to, that means it's not going to be including the points on the line. So I'm going to make it into a dashed line. Next, we need to think about which region we're going to shade. Because it's less than, that means we should be shading the values that are below this line. Next, I'm going to graph this as my equation. So that's going to start at -1, then I go down 1 to the right, 1, 2, 3, and then repeat the process. I can also go up and to the left, 1, 2, 3. Because this is a less than sign and not a less than or equal to sign, I'm going to be making this a dashed line. So that way I know that I'm not including my line as a solution. From there, because it is less than, I'm going to be shading all the values that are below this boundary line. The first thing I did was just rewrite the inequality as an equation and use that to create my boundary line. Since my y-intercept is 5, I start at 5 and then I move up 1 to the right or down 1 to the left. I have this line now. Because my sign here is greater than and not including my boundary line, I'm changing it to be a dashed line so that way I know the points along the boundary line are not going to be a solution to my inequality. Then from there, looking at the sign, since this is y is greater than x plus 5, I'm going to be shading all the values that are above this boundary line. So as I had earlier, you could shade in the whole area. I was just having fun with my iPad, but you can also just do it like this, shading in this space, as long as it's just clear which part you're shading in. On this side, I created my boundary line as I did before, starting at -3 as my slope, moving up 1 and to the right 2 spaces, or moving down 1 and to the left 2 spaces. From this line, I then look at my inequality sign to figure out if it should be solid or dashed. Because this is greater than or equal to, that means I'm including the values on this point as a solution to my inequality. So this will be a solid boundary line. So I'll just leave it as it is. Then from there, looking at my sign, since it's greater than or equal to, that means I want to shade all the values that are above my line. Okay, now let's do the reverse. If we have this graph here and we want to come up with the inequality, we're going to just first think of what the boundary line is, and we're going to write that as an equation with an equal sign. So we'll start with our y-intercept, that is -3, and then from there we move up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, so our slope is a +1. So I can write that as y equals, instead of writing 1x, I'll just write x, and then -3. From there, we can see that our boundary line here, we want to figure out if it's solid or dashed. This is a solid line. And then we need to think of which region is shaded. If it's above, that means the y values are greater. And if it's below, that means the y values are less than. Because it's shaded above, my final inequality will be y is greater than, since it's above, or equal to, because it's solid, x minus 3. Try and figure out what the inequalities would be for both of these. For this equation, the y-intercept is 0 since we start at the origin. Then from there we move up 1 to the right 4, so our slope is 1/4. It's a dashed line, and we've shaded below the line. So my inequality should be y is less than, because it's below. I'm not going to write that it's equal to because it's dashed, and then I just rewrite the other part of my equation from up here. This is my equation of this boundary line. It's a solid line, and the area below has been shaded. So I'm going to write that as y is, since it's below, that's going to be less than, because it's solid, it will be less than or equal to, and then the rest of my equation from the top, -2x plus 1.